Good morning, everyone. So let's start. This is what we did the last time. Okay, we were talking about the displacement vector, right, and its components. So the last thing I explained was that you can consider that the motion in 2D, that is motion in two dimensions or in plane, can be considered to be two separate or independent motions, right? One in x and the other in y axis. So that is, this delta r vector is actually made up of two two displacement, right? This is made up of two displacements. One is delta x, displacement in the x direction, and the other is delta y, that is displacement in the y direction. And similarly, suppose this was in 3D, then there will be a third one, the third component, that is displacement in the z direction. All right, so that is what we have got. Okay, right. Now you were given some homework, right? If you have queries or anything with the homework, we will solve those queries starting at 8:50. All right, so till 8:50 we will continue with this, right? No, I didn't make those homework questions. They were from a textbook, right? They were from a textbook. Anyways, okay then. So now we are going over to understanding about the direction of displacement, right? So let's continue with this topic. See, consider that I'm drawing the path, okay, not graph. Consider that I'm drawing the path of a body, right? Of a moving body, right? So once again, you can consider it to be like we are talking about the terrorist, right? As usual, right? So suppose the terrorist starts from this point A and let's say moves like this to this point B. So from A to B. So now I want all of you to think about this very carefully. Suppose you try to find the displacement. Suppose you try to find the displacement of that person, of the terrorist, let's say from C to D, right? If you want to find the displacement from C to D, then that would be a vector. That would be a vector like this. I'm sure all of you understand that, right? Okay. So then suppose it took a time interval delta t, right? Suppose it took a time interval delta t to go from C to D. Then of course you can find the average velocity. You can find the average velocity by taking delta r vector upon delta t vector. I don't think anyone has any problem with that, right? Displacement upon time interval. Not mixing both chapters, Vedant. We are progressing. Okay, we are not mixing both chapters. We are progressing now. Okay, એટલે third chapter માં જે હતું ને એ તો ખાલી basic હતું. That was for kids, right? It was like 9th standard. I hope you understand that. Agreed? એવું તો તમારે 9th માં આવતું હતું ને બધું. Now we are learning everything using proper ideas about vectors. Okay, so you see the direction of displacement is like this, and then once again I think we have had a talk about this. Because delta t is a scalar, and it is always greater than 0, that's why the direction of average velocity and direction of displacement are same, right? These two are in same direction, right? Okay, so that's what we have about directions, right? Again, this is average velocity, this is not average speed. Mind well, there is a difference. Okay, here we are not going to talk about average speed, right? We are not going to talk about average speed કારણ કે એમાં કંઈ ફરક નથી. Average speed is still distance traveled divided by time interval. That is still true. We don't need to change anything about that, right? Okay, so now if you take this a little bit further, right, we consider this diagram, right, and we take this, we subject it to a little bit of mathematics, right? Okay, so let's see what's going to happen. I'm going to do that on a new page. Okay, here it is. So now let's say that instead of taking from C to D, where we are getting a fairly long time interval, right, let's think of taking infinitesimal time interval, right? Let's think of taking infinitesimal time interval. I'm sorry, your nemesis is back, right? The thing that you really hated has come back again. It is that if you take infinitesimal time interval dt, right, if you take infinitesimal time interval dt, then the 2 points are not going to be very far. Basically, as you make delta t smaller and smaller, I am sure all of you do remember that animation, that this d point will not be that far. It will actually come very close to this, right? So finally, if I join 2 points like this, let's say that this is C and here is a very close point, okay, and then if I join those 2 points, then that line is going to be a tangent, right? That line is going to be a tangent. Vedant, focus on what I'm explaining, right? You are getting distracted. Okay, so I'm saying that if you take delta t to be smaller and smaller, right? That is, we start doing this. So this other point comes very close, because in a small time interval it will move very little. So now what we are having is we're getting a tangent when we join these 2 points, right? Okay, so what this means is, listen to this carefully. What this means is, at time t, particle was at C, right? At time t, particle or person, we were talking about the person. Okay. Oh, oh, I'm so sorry, something went wrong over here on my end. The screen just stopped. I'm starting it again very soon. All right, just give me a moment. Okay. Can all of you see the screen now once again? Okay, fine. Yeah. So yeah. Okay, that was an unwanted. I don't know what's happening here. So at time t, particle or person is at C. Okay. Yeah. And then at time, so after a very small time, right? See, t plus dt. This is t plus dt. So time interval is only dt, right? I hope you understood that. The particle is now at d dash. Particle is at d dash. So here, what we are doing is when we take infinitesimal time intervals, right? In that infinitesimal time interval, the displacement is from C to D dash, C to D dash. Okay, the displacement is from C to D dash. But you see that displacement is in direction of tangent, right? That displacement is in direction of tangent. So let me write what I've explained in form of sentence. Okay, in a small time interval, actually small nahi, infinitesimal. Okay, in an infinitesimal time interval, right? Let's be very clear about what we mean. In an infinitesimal time interval, the displacement dr vector of particle is along the tangent to the path, not the graph. Again, this is not a graph, this is a path. Make sure you read this sentence, right? Okay, so make sure you read this sentence and uh, you understand what this means. Again, it is that if there is an infinitesimal, if there is an infinitesimal time interval, then in that infinitesimal time interval, the displacement dr vector. See, why am I not writing delta r? You might be wondering, why am I not writing delta r vector? Because in a small time interval dt, the object or particle cannot move along, right? It cannot move a lot. Okay, it's going to move very little distance, very little displacement. So that's why we are not writing delta r vector, but we are writing dr vector. Okay, so once again, in that very small time interval, the displacement is dr vector, and that is along the tangent to the path. Okay, is that clear? I'm waiting for all of you. Make sure you understand this. Is this okay? Because this will become a very important thing, okay, when we go to the next step. Okay, then fine. So I think we are done with this point here, right? We are done talking about displacement, right? Okay, next, instantaneous velocity or velocity only, right? Velocity. You might be thinking, sir, we have already studied it. Yes, actually we have, but what we studied earlier was in one dimension. Now everything is going to come in 2D or 3D, right? That's what we are going to do. Well, but see, the basic thing never changes. Velocity is given as nothing but differentiation of position. Velocity is given as nothing but differentiation of position with respect to time. I hope all of you remember that, right? But now, position, we are not writing x for position. I hope all of you get that, right? We are not writing x for position. Now we are writing r vector. So finally, the new formula of velocity becomes this. Clear? Is this clear, everyone? Now you might have noted that I am writing v vector automatically, right? I'm not writing v. So this is where we're going to have, no, Vedant, r is position, r is not displacement, r is position. See, just like we used to write v is equal to dx by dt, now instead of position x we are writing position r vector, so it's like this. I hope that is clear. So r vector is the position, right? So y is, can we write dt vector? No way, Sanju, ગમે યા નથી કરવાનું. dt is time interval, dt is some infinitesimal time interval. ઓકે, આ એરો હું મારા શોખ માટે નથી કરતો. dt is infinitesimal time interval. Time interval is a scalar. I hope all of you remember that, right? Time interval is a scalar. No, Vedant, you can't say dx equal to dr. अरे यार, basic समझो, basic समझो. In the previous chapter, we were only talking about x axis. યાદ છે ને? એટલે position માટે શું symbol હતો? x. Now here we are talking about 2D or 3D. So r vector itself is going to be xi caret, yj caret, zk caret. I hope you get it, right? So now dr is not dx. Dr vector is much more than dx. Okay, right? It's all in vector form. So I will now once again explain why do we have vector here. First of all, in the previous chapter also I warned you that velocity is a vector, right? Here it is just going to show its true colors, right? Okay, now it's going to show its true colors, right? So v vector is dr vector by dt. We are writing that why is the velocity a vector? Why should it be a vector? Okay, let's talk about that. So I want all of you to understand the right hand side. Okay, we have got something like this here. So this is a vector and this is a scalar. Dt is a scalar, so you can always write it or you can understand it in this form. We have done this earlier, right? So you are multiplying a scalar with a vector. So when we do that, we get another vector. I'm sure you all remember that. It's just like it is just like 2 into a vector is also a vector, correct? 2 into a vector is also a vector. How many of you have understood this? ખાલી 3 જણ જ છે ચેટમાં છેલ્લા 15 મેસેજીસ થી. Are others there? Have you understood this? Okay, maybe I'm stating something too obvious. થોડુંક ભગાવું. Okay, now so that's why this thing must be a vector. Whatever this thing is must be a vector. So it's actually the velocity vector, right? It's actually the velocity vector. Okay, but this allows us to, you know, write even more detail. If you continue like this, okay, if you write this formula once again, like by using the properties of scalar multiplication of scalar and vector, right? We have talked about it that if dt is positive, if dt is positive, then v vector and dr vector are in same direction. So that's always true. So now we are going to write it as follows. Okay, so v vector and dr vector are in same direction, right? But earlier we wrote that dr vector is in direction of tangent to the path. Therefore, v vector is in the direction of tangent to the path. Is this sentence clear? Is this sentence clear? Based on what we wrote on previous page. This one. Based on this, I'm writing this. See, we are going to have some odd audio problems today because it's a very loud where I live, right? And there is heavy traffic, right? And because all of us really like loud vehicles, we don't care whether our vehicle makes any noise or not, right? So we're going to have a problem, right? In these 20 minutes that I've been teaching you, at least 150 vehicles have passed right in front of my gate. Okay. So v vector is in the direction of tangent to the path, right? I hope you understand this and remember this. This is a very important point. Okay, this is a very important point. Yeah, you can hear horn, even more than horn, the engines noises and all that. It's really like hell. I'm a big advocate for noise, or for stopping noise pollution. Yeah. Anyways, let's see whether you can understand this topic and apply it. So for example, that this is what we have, right? We are watching something from the sky, and let's say it is moving, for example, like this. Okay, let's say some particle moves from A to B in this kind of path. Okay, again, this is not a graph, right? I hope you understand that on graphs people don't make east, west, north, south. Okay, so if it's like this, right? If it is like this, then I'm just going to ask you a very simple question. Can you tell me what is the direction of velocity? Can you tell me what is the direction of velocity of particle at point number 1, A, number 2, B, and number 3, C? All right, come on. Can you tell me what is the direction of velocity of particle at A, B, and C? Use what I have taught you. Positive here, Jaikit, we are not seeing positive anywhere, right? Can I like positive, negative? Yes, by tangent, everyone. Use the concept by tangent, yes. Very good, Dhruv. Upward, downward નહીં ચાલે. Use the diagram. અરે યાર તમે થોડું ક્વેશ્ચન જે ફોર્મમાં હોય એ ફોર્મમાં આન્સર આપો. આમાં ક્યાં પોઝિટિવ નેગેટિવ છે? આમાં ક્યાં અપવર્ડ ડાઉનવર્ડ છે ક્યાંય? Okay. Now I'm telling you the answers, right? At A it is north, at B it is south, and at C it is east. Okay, basically you just have to draw a tangent, right? You just have to draw a tangent here, approximately over here, right? And somewhere over here. અરે ઝીરો ક્યાંથી થાય? This is not a graph again, this is path. અરે આ વિડિયો જેવું છે. અહીંયા હતો બબલો, પછી બબલો આમ ગયો ને આમ આવ્યો બબલો, right? This is not a graph. હા તો હવે બીજું શું કહું? I thought let me make it a little bit light hearted. Okay, so once again it is important to remember that direction of velocity is along tangent to the path. બરાબર? આ path છે. I can understand. See, I can B ઉપર સ્ટોપ થાય તો એવું મેં ક્યાં કીધું કે B ઉપર સ્ટોપ થાય છે? એવું મેં કીધું? It's possible that the person moves further like this. Okay, we don't know, we are just observing from A to B, that's it, right? Remember, initial does not mean the velocity is zero, right? Velocity may not be zero at initial, and similarly final also the velocity may not be zero. Okay, anyways, so direction of velocity is along tangent to the path. This is something that you should remember. Okay, I know you can get confused here, right? The other point that we have been talking about in the third chapter was that velocity is tangent to position time graph. Do you all remember this xt graph? Velocity is the slope of tangent to xt graph. આ બે આખી અલગ જ દુનિયા છે. Let me tell you that, right? This sentence and this sentence, they are totally different because number one is about path. So that's like what the object actually moves on, and a path કહેવાય, બરાબર ને? And this is about drawing a graph. Okay, graph is what we draw on paper, right? So please make sure you do not get confused between these two, right? Okay, at this juncture I want to mention one more point related to this. In the previous chapter I taught you this. મને યાદ છે, એટલે તમને યાદ હોય કે નહીં એ તમે જાણો, મને તો યાદ છે કે મેં તમને શીખવાડ્યું હતું. It was that object moves in direction of velocity. Do you remember that? And not in direction of acceleration. See, that is still true here. That is still true over here, right? It is still valid. In fact, our sentence 1 and this sentence actually mean more or less the same thing, right? I'll tell you how. If you would go back and look at this one, what is this telling you? It is telling you that displacement is along the tangent. Okay, સરસ. And now here we have written that velocity is also along the tangent, right? Okay, we have written displacement is along the tangent and velocity is also along the tangent. So it means that the object is moving, and the direction of velocity both are actually same, because dr vector and v vector are same directions, right? So I hope all of you get that ultimately we are just representing this sentence in a different form, right? Okay. So let me ask you a question which is, in a slightly different manner, right? That will hopefully solve confusion. Suppose some object is moving in a circle like this. Okay, some object is moving in a circle like this, let's say. So if I ask you that at the point A, object is moving in which direction? At point A, object is moving in dash direction. Can you answer this question? At the point A, object is moving in dash direction. Okay. Jay, you got it wrong. No, Dikshita. અરે આમાં ઈસ્ટ ને એવું ક્યાં લખ્યું છે? અરે ધ્રુવ, બે આન્સર ક્યાંથી આવે? Wrong. The correct answer is at the point A, the object is moving in this direction. Again, clockwise nahi. Clockwise is not a direction of motion, everyone. Okay, I want all of you to understand that object moves in direction of velocity. You can't say velocity is clockwise. That is rubbish. Okay, right? This is wrong. So you can't say clockwise. So the correct answer is that the object moves in positive x direction. I hope that makes it clear, right? I hope that it is clear. Suppose I take a point B here. Then can you tell me at B it moves in which direction? At B the object is moving in which direction? Okay, positive y direction, that is right. Okay, positive y direction. Yeah, fine. I think you have got a good grasp of it. Okay. Right. Now let's go to calculating velocity. We have already studied this formula. Okay, this is the new and improved formula. આવું લખેલું હોય ને એડ્સમાં, અલગ અલગ વસ્તુમાં, new and improved formula. Okay. So please remember this new and improved formula. But earlier we have seen that r vector is equal to xi caret plus yj caret plus zk caret. લખવું હોય તો again to remind everybody about it. Suppose here is some particle, then the position vector, I repeat, the position vector is a vector drawn from from the origin to that point, right? Suppose here is the particle, so this is its position, so this will be r vector. Okay, so r vector has two components. એવી વાત થઈ હતી આપણે, યાદ હોય તો, right? I hope all of you remember this. Okay, so let's put this here. All right, so that's what we have got. Well, that is unavoidable. I can't do anything about it. Now we will use differentiation rules. Okay, get ready. Differentiation is back. Wait, I hope this is not a problem for anyone, right? This is just the addition rule. Okay, and now you see we have to do differentiation. We have to do differentiation, but I caret and j caret, they are some fixed unit vectors, right? I caret and j caret are some fixed unit vectors. હા સ્પેરોઝ નો અવાજ આવે છે એ એકચ્યુઅલી સ્પેરો નથી, સનબર્ડ છે. અમારા ઘરમાં બહુ બધા સનબર્ડ રહેતા હોય છે. Okay, anyways, let's continue here. So because I caret and j caret, they are સનબર્ડ ઇન ગુજરાતી નથી આવડતું, એનું નામ ગુજરાતીના બર્ડના નામ બહુ ખતરનાક હોય. But it is not your typical house sparrow, right? It is not your typical house sparrow. Okay, that's enough to know. So here I caret is a constant, we can leave it out, and now inside here we have to do this, and over here we have to do this. Okay, I don't think this surprises anyone. Kick the constant out, right? We kick the constant out. Okay, now this is where it gets interesting. If you would look at this whole thing, do you realize that this is like x component, but of what? Of velocity. And this whole thing gives y component of velocity. Is this clear? What I've marked here, are these two things clear? મને લાગે છે જ્યાં સુધીમાં સ્કૂલ ચાલુ થશે ને ત્યાં સુધી આપણા ક્લાસમાં સિંગલ ડિજિટમાં હશે સ્ટુડન્ટ્સ ઓનલાઈનમાં. બાકીના બધાને એમને જ આવડી જવાનું છે. બધા બહુ જોરદાર લોકો છે. વ્હાઇટ હેડ જુનિયરની એડ જોઈને બધું શીખી જશે. Okay, so this is x component of velocity and y component of velocity. So if you remember earlier we did it like this. Suppose you have got a vector, then we write it like this. યાદ છે બધાને? Right? So just like that we can also write it like this. Okay, is this clear? What I've written over here, is that clear? This one. So based on that, so by comparing with v vector equal to vx I caret plus vy j caret, I can write vx equal to dx by dt and vy equal to dy by dt, right? Just look at this and this. Okay, clear? So you get this. And similarly when you look at this and this, you're going to get this. Okay, now this, what have we got here? This is interesting. We have got that the x component of velocity can be found by doing differentiation of x coordinate. Yes, and we can say that we can get y component of velocity by doing differentiation of y coordinate. Do you agree with these two sentences? x component of velocity by doing differentiation of x coordinate, y component of velocity by doing differentiation of y coordinate. Okay. So this is what I meant when I said independent. Okay, this is what I meant. That if you look at this equation, have a look at this equation. આમાં ક્યાંય y આવ્યો? No. Similarly, if you look at this one, આમાં ક્યાંય x નથી આવતું. Right? So what this means is x and y axes can be considered separate. મારા હેન્ડરાઇટિંગ બગડી જશે સાવ આની ઉપર લખીને. Can be considered separate, right? So Sahil, what are you writing? I didn't understand anything. So x and y can be considered separate, right? So if you look at this has been separate from all the way from the start. It was like this, correct? Okay, they are separate, x, y. Then if you find displacement, then also they are separate, correct? You see, this is where I said the two are independent. I hope you remember that, right? This is where I explained that the two are independent. Now we are getting the next thing. We are getting that the velocity itself is in two separate parts like this, where once again Vx has nothing to do with y and Vy has nothing to do with x. Vedant, if you don't pay attention here, you are going to be the next Chintu. Is this clear? So in all the three, it's like, okay, आगे से चला रहा है. What? Independence, right? Okay, this gives this, right? And then if we write small displacement, then that small displacement should also be written like this. Is this clear for small displacement? Is this line understood, people? This one? Yes, Falak, that's a lot of emphasis on independent. Agreed, it is, right? Okay, so you know what sometimes you could do is, suppose you divide this whole equation by dt. All right, we get this one. I hope you realize that. Clear? Okay, let's go to next step. Okay, let's go to next step. હવે દોડ દઈને એક્સેલરેશન આવી જશે પિક્ચરમાં. Is this equation clear? Is this equation clear? Okay, then I hope all of you can understand that we could write it as d by dt vx I caret plus vy j caret, because we are putting v's value. Okay, we are putting v vector's value from here. So then if I separate it once again, it's going to become this dvx by dt I caret plus dvy by dt j caret. And once again, the independence of the two axes holds. This is x component, right? This is x component of what? Of acceleration. And this is y component of acceleration, right? So if I want to compare, once again, this is going to be this, right? Ax, ay, okay? Ax for x component, ay for y component. So that's why we can write ax is equal to dvx by dt and ay equal to dvy by dt. Okay then, right? I hope you understood this whole chain, right? I hope you have understood this whole chain that I'm writing on the side. Right? Yeah. So Krisha has so many doubts. Okay. So that's it for today's theory, right? Or discussion. Now we will solve your doubts. Okay. હું એકચ્યુઅલી રાહ જોતો હતો કે જેટલા ઓછા થઈ જાય ને એટલા ઓછા, વાંધો નહીં. પણ કોઈ બહુ જતા નથી. કોઈને જવું હોય તો જઈ શકો છો. યુ આર મોસ્ટ વેલકમ ટુ લીવ. Okay. Just give me 1 minute. I will get the questions, right? I have them, but not on this laptop. Yes, Falak, you will be remembered. Okay. Yeah, who sent it to me? Let me check. School sent it to me, right? School. 11th standard physics homework. Yeah. Yeah, okay, everyone. Those who don't have doubts can leave, no problem. You are free to do that. Okay. I'm not going to teach anything, but remember that solving your queries or doubts is actually very important. You get a lot to learn from that. Okay. Okay. Question 7. Right. Question 7. Yes. Sahil, you said 7B. Forum, you said 7. Okay. So let's start with question 7. All right. Uh, Here, this is VT graph, and you have to find distance traveled. So you just need to find the area under the graph. That's the basic principle, right? You just need to find the area under the graph. Now, for A, I don't think it's a problem, right? Because t equal to 0 to t equal to 10 seconds is just a simple, nice triangle, right? So that's not a problem, I believe. Yes. Okay. So B. Now for B, okay, it says internet connection is unstable. It's stable. Come on. For B, you have a graph like this, 2 to 6 seconds. All right. So somewhere over here is 2 seconds, and maybe this is 5, and somewhere here is 6 seconds. So now you have to find out the area of this part. I know it's extremely weirdly shaped, right? So what I suggest everyone does. Okay, everyone, are you there? Is everyone there? Can you listen to me? Can you hear what I'm saying? Hello? Can you hear me, everyone? Okay, right. Let me just share the screen once again. All right, then. So here at this point, it is given in the graph that the velocity is 12, right? Over here the velocity is 12, right? And here it is 0. So if you want to find out, it's all blank. You can hear me, right, all of you? Okay. Yeah. So I was saying that because this velocity here is 12 meter per second, if you want to find it for this parallelogram, you see here this graph is a straight line. VT graph, straight line means it's constant acceleration, right? So for 2 second to 5 second, okay, here we are seeing that it's constant acceleration, right? For every, actually for 0 to 5 second, the acceleration is constant, right? Because here the graph is a straight line. So what we do is, if we find the acceleration, we can find the displacement very easily, right? If we find the acceleration, then we can find the displacement easily. So listen to this carefully. Because acceleration is constant, if we use v equal to v0 plus at, initial 0 seconds, so 0 velocity, final, let's say over here, right? So 5 seconds, and velocity is 12, right? Final velocity 12, initial velocity 0, time interval 0 to 5 seconds. So you get a is equal to 12 by 5, right? That is 2.4 meter per second square. Now once you have this a, once you have this a, it is possible, once you have this a, it is possible to find out what's the velocity here. So if I want to find velocity at 2 seconds, if I want to find velocity at 2 seconds, I will use once again the first equation, v equal to v0 plus at. Final velocity at 2 seconds we don't know, initial velocity at 0 second we know. Okay, so you get it like this. So that's going to be 4.8 meter per second, right? So now if you know that this is 4.8 meter per second, right, then I think you can find the area of this parallelogram, right? Once you know that this velocity is 4.8 meter per second, you can find the area of this parallelogram, right, by simply doing half into parallel sum of parallel sides. So that's going to be 4.8 plus 12 into distance between them, so 3. Yes, it's sorry, it's a trapezium. Yeah, I'm sorry, trapezium. I was saying parallelogram, I think. Okay, sorry, it's a trapezium. So for this trapezium you can find it, right? Okay, so this would be for 2 to 5. Now for 5 to 6 you will have to do something similar. Okay, for 5 to 6 you have to do something similar, but for that you have to consider this graph, this part of the graph, which is also a straight line. So find new acceleration and find this area. Once again, same procedure, I repeat, same procedure, but you'll have to do the calculations again because the values are changed. Okay. Question 5. Yes, Divya, that is right. It will be minus 2.4 acceleration. Question 5. Okay. Question 5. What about question 5, Raj? Be specific. Ask something. આ તો આખો આટલો મોટો ક્વેશ્ચન છે એમાંથી શું નથી આવડતું. What about question 5? અરે નંબર 5 પણ શું નંબર 5? A અને B બે જ છે. Don't joke. You have to find velocity, you have to find acceleration, you have to find average velocity and average acceleration. આ ચારેય વસ્તુ નથી આવડતી તો શું કર્યું આખા થર્ડ ચેપ્ટરમાં? કંઈક તો આવડતું હશે ને? Okay, X is given. Raj, I will expect answers from you. Okay, તું ડાઉટ પૂછે છે તો તને તો તારાથી તો થવું જોઈએ. So A, velocity. How do you find velocity from position? બોલો ચલો. How do you find velocity from position? हाँ तो करो बोलो. dx by dt નો આન્સર બોલો. ચલો ચલો જલ્દી. Yes, Vedant, but this is from third chapter. Raj, I'm waiting for your answer. Yes, Divya, Vishwa, it is right. Raj, are you sure about your differentiation? It is going to be, differentiation will be 3t square plus 8t minus 2. Right? We always have to use this rule. Right? So now you can put the value t is equal to 4 and get the answer. Same procedure for acceleration. If you want to find A from V, then -2 is constant. એટલે જ આ -2 અહીંયા આવ્યો because -2 is constant. I hope you still remember, kick the constant out. Okay, Raj, I think you should ask me personally on the phone. Okay, that will be better. Now, any other question, anyone? If yes, please say it. I'm still here. Question 8. Okay, Preet, Kavya, I've got your request. I will answer that also. Okay, question 8. All right. ના વેદાંત એવું નથી, 5th ચેપ્ટરમાં આવશે પછી. ઓકે, question 8. Okay, so for question 8, what we have is we have to draw a diagram first of all. Diagram વગર ફિઝિક્સમાં બધું ધૂળ જ છે. So if you consider that motorcycle starts from A, goes to B, and then goes to C, so let's say this distance is 120 meter, right? And this is what we don't know, right? Okay, and here in the first part its acceleration is, in the first part its acceleration is 2.6. In the second part its acceleration is minus 1.5. Now it is given that it, okay, it accelerates with minus 1.5 meter per second square until velocity becomes 12 meter per second. So over here the velocity at C is 12 meter per second. Is this diagram clear? Okay, now you have to find the total distance traveled. એટલે એટલું જ find કરવાનું છે, પછી 120 add કરી દેવાય. Simple. So now we have to do separate calculations. So let's do calculations for B to C. And we can do that, we can use equations of kinematics because this is given, so it's a fixed value, it's a constant, right? Okay, so for B to C, suppose you try delta x equal to v0 t plus half at square. You can clearly see there is a problem. We don't know how much time it took to go from B to C, right? So that's why this is a bad idea. Then you can try the other one, 2a delta x equal to v square minus v0 square. Here also there is a problem. We know the final velocity. See, we are doing B to C, so B is initial and C is final. So we know the final velocity, but we don't know what's the velocity here, right? But we can find that by doing calculation of first part. So that is what my hint is. So use first part, okay, to find velocity at B. All right, once you do that, you can do the calculation of part 2, right, and find delta x for part 2. So final answer will be 120 plus delta x. So in these three sums you get the whole, I mean these three steps you get the whole sum. All right, clear? Would anyone like to ask anything more about this? Again, diagram is key. Again, I'd like to request all of you that sometimes if you cannot understand in class, no problem, you can ask me in the class, or even then if you don't understand, you know, because in class I will not explain it in full detail, right? Sometimes because lots of people are there, right? If you still don't understand, you can always contact me personally. I've told you that, right? I will not tell you the answer, but I'll tell you how to get it always. So if you have patience, no, Ankita, no. 12 meter per second is not velocity of object at point B. Read it carefully. You have misunderstood the question. Okay. After 8, I think there was a request for one more question. There was a request for one more question. What was that? 3? Kavya, you said it, right? 3. Yeah, okay. Kavya, are you still there? Are you there with us? Okay, yeah, fine. Yeah. Question 3 now. Let me just find it over here. Question 3. Okay. So, right, Kavya, I'm going to ask you this because it's your question. Question 3 says, how long does the particle take, right? So that means we have to find some time, right, to come to rest. What is meaning of rest? Can you tell me that? What does that mean? What is meaning of rest? What is meaning of rest? Final zero પણ શું zero? Final marks zero? Kavya, final marks zero? હા, ફાઇનલ વેલોસિટી ઝીરો. વેરી ગુડ. અરે આવડે જ છે, કેમ ડાઉટ આવ્યો ખબર ન પડી મને તો. તને આવડ્યું તો ખરું. સો વી શુડ હેવ the point where the velocity becomes zero, that is called rest. Okay, so y is given, right? Y is actually position. I hope you remember that when we were doing questions of ball throwing up, down, etc., I told you that instead of x we can take y also, right, and put all equations like this. And okay, so y is given, so this is position. From y, how do you find v? From y, how do you find v? I'm sure you know that. From y, how do you find v? From position, how do you find velocity? Yes, dy by dt. Very good. બસ તો એટલું કરો. So you do dy by dt, right? So what will you get? Dy by dt is going to be, have you done that? What is dy by dt? Yes, that's right, Vishwa. ઝીરો તો આપણે મૂકવાનું છે એટલે ટાઈમ મળી જાય, પ્રીત. Yes, Divya, that's right. Kavya, I'm waiting for your answer. Yes, very good, Preet. Okay, so y is given to be minus 2 by 3 t square uh, plus 16t. So its differentiation is dy by dt is equal to minus 4t by 3 plus 60. Yes, so this is velocity. Now we are given that we want to find t when it is at rest. Okay, so we want to find t when v is 0. So put v equal to 0. ચલો મૂકી દીધું. હવે solve કર નાખો. Okay, that easy. Clear? Ankita, I answered your question. I hope you have seen it. All right, any more questions? Anyone? Yeah, the question is when will school reopen? 1st January, Preet. I'm just joking. It will not open before 1st January, right? I think we'll have at least 1st January, right? And I cannot say full day, half day, anything. I don't think how everything will turn out to be, right? Okay, this is my guess. I don't have information. This is my guess. Okay. Vedant, in an actual class, you would be repenting that you even made that kind of comment. Okay, any more questions, anyone? I don't think so. That's it. Let's end this class. Okay, yeah, I will send you important points. Don't worry. Goodbye, everyone. See you tomorrow.